We're going to do lessons 7-4, day 3. This first part, we're going to review complex fractions. So just a few reminders, things we've done in the past. Fractions are division expressions. So 2/3, zoom in here, 2/3 can be written as 2 divided by 3. So just keep that in mind when we're talking complex fractions. I'm going to kind of reference that a lot. Another thing to remind yourselves is that when we are dividing fractions, we actually multiply by the reciprocal. So keep, change, flip. And then adding and subtracting fractions does require the same denominator. We saw that yesterday. All right. To simplify complex fractions, so again, I kind of wrote out the steps. If you want to write them down, totally fine, but I'll do an example with them as well where I explain each of these steps. So first, we're going to perform the operation in the numerator and denominator, if necessary. So if there's adding or subtracting in the numerators or denominators, we want to do that first because we want to simplify it. We essentially want to have it so we just have one item in the numerator and one item in the denominator. So if there's addition happening anywhere or subtraction happening anywhere, we want to get that out of the way first. Step 2, we'll write it as a division problem. I said 2/3 is the same as 2 divided by 3. So once we have just a numerator and a denominator, we're going to rewrite it as a division problem. After that, we do keep, change, flip, and then we just multiply it like we've multiplied fractions before and simplify if we need to. Complex fractions, we're just dealing with no letters right now, okay? So we're just going to review with numbers only. So let's look at an example here, okay? This is our first one. This is a complex fraction. It's complex, hence in the name. It has fraction, 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 fraction. Okay, we have 2/3 minus 1/2 over 3/5. This whole piece up top here, that's your numerator. This bottom piece is your denominator. Denominator is fine. It is one single item. It's 3/5. Okay, that's what we want. We want just one piece. Okay, the numerator, however, in this one is not just one fraction or one number. It's being subtracted. So we want to simplify that guy first because I want it to just be one thing up there. So in order to do it, I'm going to cover up my denominator just for now. So I'm only going to focus on that numerator. The problem is I cannot subtract these because they have different denominators. So I have to get them to be the same. Well, how do I get 3 and 2 to be the same? What number can they both multiply to?
6.
So 6, okay? So how do I get 3 to be 6? What do I multiply by? 2. If I multiply the denominator by 2, I have to multiply that numerator by 2. So that first one becomes 4/6. What about the 1/2? What do I have to multiply both top and bottom by? 3, okay? So we have minus 3/6. And I'm working with single numbers, easy, because eventually, guys, this is going to turn to variables. So we're going to add letters. So I want to practice while we can now on these smaller ones. Now that they're the same, 6 stays the same, 4 minus 3 is just 1. So now my numerator is a single piece. That's what I wanted, okay? I'm going to uncover my denominator now, and I could just write my denominator directly under that guy, okay? I just moved them all over. Now that we have one thing in the numerator and one thing in the denominator, now we're going to write it as a division problem, okay? We can rewrite this guy just like 2/3 is the same as 2 divided by 3. Same idea here. 1/6 is the same as, 1/6 over 3/5 is the same as 1/6 divided by 3/5. Numerator divided by denominator, okay? Once we have that, we keep, change, and flip. So keep the first guy, 1/6. Change to multiplication, and flip the last guy. Once we have it as a multiplication, we can just multiply the tops, multiply the bottoms. So we have 5/18. That guy cannot simplify any further, so he's 5/18. Here's our next one. 5/2 minus 7 over 5, all over negative 2/3 plus 4. So write that guy out. So we have numerator on top, denominator on bottom. Numerator has an operation. That means we have to simplify it. Denominator also has an operation, so we're going to simplify those. Okay, we need to do that operation before we can move on. So I'm only going to do one at a time though. Okay, so I'm only going to focus on the numerator for it right now. I won't cover this up just in case people are still writing it, but I'm only going to worry about the numerator. 5 over 2 minus 7 over 5, the denominators are not the same. So how do we get 2 and 5 to be the same? Yeah. Times 5 here, times 2 here. That means what am I going to multiply the 7 by? 2. And the 5 up here by? 5. Anything you multiply the denominators by, you got to multiply their numerators by. All right, so that gives us 25 over 10 minus 14 over 10. Well then, what's 25 minus 14? 11 over 10. So the numerator is simplified. So now we're going to do the same thing with the denominator. I have negative 2/3 plus 4. But the 4 does not have a denominator. What is it? 1. Good. How do I get them to be the same? Yeah, multiply the 4 and the 1 by 3. I don't have to touch the negative 2/3. All I'm going to do is put that negative with the 2. Because if I drop it down with the 3, then we're back to them not being exactly the same denominator. Okay? Oops. That should be plus 12 over 3. Okay? So our negative 2/3 stay the same. Plus 4 times 3 was 12. 1 times 3 is 3. So then, what do we get there? 10 over 3. Okay? So now, we don't have any addition or subtraction in either the numerator or denominator. So now we can rewrite this guy as a division problem. 11 over 10 divided by 10 over 3. Then keep, change, flip. Keep the first, change the sign to a multiplication, flip the last. Now we can just multiply the numerators together. We get 33. And the denominators together, we get 100. We can't simplify that any, so it stays 33 over 100. We have 4 over 3/4 minus 3/2. The numerator just has a 4, so that's fine the way it is. The denominator, not okay, because we are subtracting. So do the subtraction first, okay? I have 3 over 4 and 3 over 2. I want to get them to have the same denominator. So what do I have to multiply? And by what? Yeah, I multiply by 2. So 2 here and 2 here. Okay? So I have 3/4 minus 6/4, right? 3 minus 6 is negative 3 over 4. The numerator, I didn't have to do anything with. It's just a 4. So I just drag it on over. Now rewrite it as division. 4 divided by negative 3/4. Keep, change, flip it. Keep, change, flip. 4 times 4 over negative 3. What's really over or underneath this first 4, this whole number? 1. Good. So then we get 16 over negative 3. But I don't like keeping a negative in the denominator, honestly. So I want a negative. You can pull the negative outside and write it outside the fraction, or float it up top with the 16 is fine too. All right, I'm going to have you guys try number 4, okay? So we have 1/4 plus 5/4 over 4. So I'm going to have you copy the next problem here in a second. So we have x over 3 over x plus 1 over x. So we are introducing a letter. That means we will have restrictions, okay? But we're starting small, okay? The denominator, that we do have to simplify first, but the bottoms, the x, are both x, right? So we can add those guys together. 3 plus 1 gives us 4 over x. Now we can rewrite it in division, okay? Remember, x is my numerator, 4 over x is my denominator. So I write it, x divided by 4 over x. Keep, change, flip. Keep the first, change to multiplication, flip the last. So keep, change, flip. There's really a 1 underneath this x, so when I multiply, we get x squared over 4. I can't simplify that any. And now to list my restrictions, I have to go back to what is in my denominators. So first off, these guys are denominators. So if there's just an x there, what is one restriction? X can't be 0. Good. Okay. Now, this whole thing also was the denominator, right? After we added this together, isn't this another denominator? So as long as this guy can't be 0, then we're good, okay? So this also can't be 0. We already listed it, so I don't have to worry about listing it twice. So the only restriction here should be the x can't be 0 part. Get another guy here. Okay. Okay, expanding a little bit more. So not just an x, but now we have a binomial in a denominator. So we have 16 over m minus 1. This is our numerator over 16 over 5 minus 16 over 25. That's our denominator. So we tackle those first. The top is just 16 over m minus 1. I can't do anything with that, so that's going to stay. The bottom, however, I can subtract, but I need the denominators in that bottom to be the same. Right now, one's 5, one's 25. So I'm going to make them the same by multiplying that guy by 5. When you do 5 times 16, what do we get there? Okay, and we still have the minus 16 over 25 because that didn't change. So keep going with it, okay? 25 is the same denominator. That was the goal of it. Subtract your 80 minus 16. Okay? What's that? Yeah, can we simplify that at all? I don't know if we can. That's why I was just looking at it real quick. I don't think there's a number that reduces it down. We could check. If you did 64 divided by 25 and converted it back to a fraction, I don't think there's a number though, is it?
Square root, maybe.
Oh, yeah, no, that's not reducing though. Yeah, that's square roots. Okay, so we can't reduce that any. All right, the top is unchanged. So this is our numerator, remember? Numerator, oops, want a different color. Denominator. So now we're going to rewrite it as division. Numerator, 16 over m minus 1, divided by denominator, 64 over 25. Keep, change, flip. So keep this guy, change the multiplication, flip this guy. Now, this one here, it's m minus 1 times 64. So we can leave it separate and write it as 64 times m minus 1 like this. I would recommend that because 400 over 64, we can reduce that fraction. So what did you say it was? Sorry. 25 over 4. And then we still have our m minus 1. Our restriction. What's our restriction? This time we have m as our variable, not x. So m can't be. Look at your denominators. M minus 1 is in a denominator. So it cannot be 1. Good. And looking at the entire thing that was doing the dividing, that's 64 over 25, there's no m in that, is there? So we don't have to worry about that. If there was an m here, I'd have to factor in that, oh, it can't be 0 either. Because if it was like 25m, then that would also make it fail. Okay? So making sure we check all the spots that are denominators, not just the answer denominator. Okay? Let's try this guy. So we have 9 over x plus 2 over 3x. Numerator, denominator. I'm going to work with the denominator here because I need to add those first. Can I add them the way they are? I got to multiply. Which one? Yep. By what number you said? 3. Awesome. Multiply by 3. That way we get them both to be a denominator of 3x. So now I have 27 over 3x plus 2 over 3x. Now I can add them together. 29 over 3x. Can I reduce 29 over 3 at all? Nope. Okay, so we'll just leave it. The 9 in our original numerator is still there. I didn't have to do anything with it, so I'll just drag them over. But now we're ready to write our division problem. Numerator divided by our denominator. So we have 9 divided by 29 over 3x. Keep, change, flip. 9 times 3x over 29. Remember, there's just a 1 there, so 27x over 29. 27 over 29. We can't reduce that guy any. And so now the last thing is just the restrictions. What would make this fail? X can't be what number? Well, it's not in the denominator or here, but go back to the beginning. Where did we start? We had 3x in the denominators. So yeah, 0 would make it fail. Awesome. Okay. And I could even go after we added it, I could double check what would make this 0. Oh, 0 again would make that 0. I don't have to write it twice. I already had it. Okay? This next guy here, x over 6 minus x over 3, all over x minus 5, or sorry, all over x over 5 minus 7 over 10. Numerator, denominator, both have stuff going on, and both cannot just be subtracted as they are, right? So we got to get the denominators to be the same. So let's look at the numerator first. What can we make? How can we make these guys the same? 6 and 3, yeah, times 2. Awesome. Okay, so we have x over 6 minus 2x over 6. Good. What's x minus 2x? Negative x over 6. So that's my new numerator. I can't just drag over my denominator. I gotta rework him also. 5 and 10 can both get to be 10, right? I can multiply my 5 by 2 to make it 10. That means I have to multiply that x by 2 as well. Now this guy, 2x minus 7, the best I can write him is 2x minus 7. I'll even throw parentheses around him to know that, hey, he's kind of together. He's a binomial. He's going to stay that way for now. Bring my big division over. This is our numerator. This is our denominator. So now we get to rewrite it as a division problem. So negative x over 6 divided by 2x minus 7 over 10. Keep, change, flip. Keep the first guy, change to multiplication, flip the second guy. Multiply straight across, numerator with numerator. So negative x times 10 is negative 10x. And then my 6 times 2x minus 7, I'm actually not going to distribute it yet because I want to make sure that I can simplify this fraction. If I distribute that 6, then I won't know that I can reduce that fraction at all. Okay, if we look at this part, this negative 10 times x and this 6, I can reduce that negative 10 and 6. They're both just factors. They're not adding or subtracting with anything. So we can reduce them both by 2, right? So we would have negative 5x over 3 times 2x minus 7. That's the most I can reduce that guy down. And so I'll leave him like that. What are our restrictions? What would make this fail? X is our letter, so x can't be what? Let's see. Yeah, 7 over 2, because if I move that 7 over, then divide by 2, so 7 over 2. Awesome. Whoops. Try that again. I'm going to look back in the beginning, okay? Yeah, I think we're good. That's the only one that would restrict it, because this whole thing, yeah, if that was 0, which that's still 7 over 2, so I don't have to worry about that being an extra restriction. We already have it, so we're good to go.